Good morning, everyone. Can you hear me? Cool. Thank you all for coming. I'm so excited to be here. Paris is a beautiful city. I'm from San Francisco, and my name is Imad Elyafi. I'm a software engineer on web core experience team at Pinterest. I started using React about 3-4 years ago when I was at Facebook, and one of the projects that I've been working on last year is React migration. And today I'm going to tell you a story of our journey to React. We'll take a look into challenges we faced and techniques we use while migrating Pinterest profiles to React. If you have any questions, please make a note and I'll be happy to answer them in the end. So today's presentation is broken into 4 major parts, and the first one is about why we choose in React and why we had to migrate from the existing framework at all. And the second part is about how we prepared our infrastructure before we were able to build something in React. The third part is one of the most exciting parts for me, is about A/B testing and UI experiments. Basically, I'll tell you how we were measuring the impact and how we were making sure that the newly created React components and the whole architecture works better than the old one. And the last part will be about where we're at now. Basically, I'll tell you how our developer experience changed after adoption of the React. So, why React and why we had to move from the existing framework at all? And the old framework was introduced in 2013 with a major redesign at Pinterest. And this framework was based on object-oriented JavaScript paradigm and uses component-based hierarchy. It's very similar to many other frameworks that were introduced 3, 4, 5 years ago, and you may still find something similar in your projects. But nowadays, Denzel is outdated, and basically, all the modern frameworks are fantastic compared to what we had before. And one of the biggest questions, why we actually choosing React and not decided to migrate to Angular, Meteor, Knockout, Ember, or any other frameworks. And as I mentioned before, all the modern frameworks are fantastic compared to what we had before, and building single-page web applications nowadays is much easier. We had a list of requirements for the new framework, and you can see them on the slide. The very first one was having large developer community, and React has a huge developer community, and we're excited to be part of this developer community. The second requirement was design patterns, and we tried to find framework which has design patterns that are very compatible with the existing stack, which makes the migration much easier. The third requirement is isomorphic rendering, and it's very important for us to have a solution for isomorphism, and I will tell you later why this is so important for us. The first one is performance, and we did a bunch of tests and benchmarking, and we realized that React performing is very well, and you probably all know about Virtual DOM that helps us to prevent a lot of performance bottlenecks and issues. And the last requirement was developer experience, and our developer experience has changed a lot after adoption of React. So this is our old stack, nothing too crazy. You can see Python Django web server, Jinja Renderer on the server side, Nunjax on the client side. The web app is powered by Backbone, and probably all of you are familiar with this stack and using something similar. But having all of these and being on board with Webpack Module Bundler, Jest unit tests, many other frameworks and tools has changed our life a lot, and developer experience is completely different now. So just to give you an example of scale that we operate at, we have 175 million of monthly active users, which is more than population of the biggest country in the world, Russia. We serve 150,000 requests per second. And this is just to give you the example of scale that we operate at. So now let's talk about migration path to React. And since we're constantly shipping features and we're running hundreds of experiments simultaneously, we can't stop development process in order to rebuild the whole web app from scratch in React. And while it's relatively easy to build a whole web app in React from scratch, migrating a service which is constantly changing and has millions of users is a much more complicated challenge. It's like changing engines of an airplane while you're mid-flight. How many of you have tried to rewrite a web app from scratch before? I think a lot of hands. I tried to do this before, and it was a nightmare. I ended up in a situation where I had two web apps that I had to support simultaneously. The old one, which is still in production, and product engineers are constantly changing and shipping features, and the new one, which is still under development process, and you kind of have to port all these newly created features to the new one, and it's like constant race condition. Not a pleasant situation to be. So how can we avoid this? And the only way to avoid this is to rewrite our web app piece by piece while the rest is still run by the old framework. Thus, we will not have to implement features in two places, and we will not have to stop the development process. So we're coming to this idea of so-called hybrid app. It's an app where two frameworks coexist together for a certain period of time, and this period of time is a time of migration from the old framework to the new one. And how can we make this hybrid app? And the very first thought, maybe it's not that complicated, but let's take a look into the list of all possible challenges. So first of all, React is a JavaScript framework. And how many of you have JavaScript server-side rendering on the server side? Only a few hands. And it's not a very common thing yet. But having JavaScript rendering in languages like Python, PHP, or Java, or anything else is not common at all. And the very first step we had to do is to prepare our infrastructure before we could actually build something in React. So, and for that purpose, we had to enable JavaScript rendering on the server side. Some of you may ask a good question. Why do we actually need a server-side, an isomorphic or universal rendering in our web app? And there is two reasons. The very first one is that our engineers will not have to build their templates twice. Basically, we build one template and it works on the server side and the client side. You save a lot of engineering time. And the second reason is SEO. Even though nowadays search engines that can execute JavaScript and they can render pages that are single-page web apps, it's still better for SEO purposes to send the initial markup as an HTML. The second challenge is to render newly created React components inside of the old frameworks and inside of your old framework and template language. And even though React is very flexible in terms of rendering, there still might be challenges. For example, what if your templates are stored in separate files? Or what if your template language is a custom-built language which does not exist like in JavaScript? And such example is Jinja templates on the server side in Python and Nunjucks on the client side. The third challenge is reusing the existing data sources and API layer library. So basically, more likely you have something that is built on top of AJAX requests, which does all the communication with the API. And you probably really want to reuse this library, at least for the first period of time, unless you really want to migrate everything at once, which actually will be too complicated. So how can we make sure that we can reuse and feed the data from the server-side and API? And the last challenge is measuring the impact. How can we make sure that the newly created architecture and React components actually work better than the old ones? And what if we introduce some performance issues? Or what if we introduce bugs? How can we make sure that we can address all these issues, and how can we make sure that we can measure the impact? So here we'll outline our 4 main challenges, and now let's dive deeper into each of those. And let me give you a very high-level overview of our web app architecture. And you can see there is nothing too crazy. Python Django web server, backend API. We have user agent, and whenever user agent sends a request to our Python Django web server, it renders the whole HTML and sends it back to the user agent. So after that, browser spawns a bunch of additional requests in order to obtain all the assets like JavaScript, CSS, images, and etc. So once the web app is initialized, all the subsequent requests are sent only in order to obtain additional data from the API. So basically, we render only the very first page on the backend, and all subsequent renders are happening on the client side in the web app, which is powered by Backbone and the old framework. So now let's talk a little bit about Jinja and Nunjucks. These two templating languages are very similar, almost identical, and they let us to have so-called isomorphic rendering. Jinja is a Python version, and Nunjucks is a JavaScript version. The only caveat of this approach was that we had to have two sets of libraries and utils, and whenever someone adds a library or utility, we had to test it twice, implement it in two places, not the best approach. Also, on this slide, you can see a code snippet, which is a Nunjucks or Jinja templating language. Is anyone familiar with Nunjucks or Jinja at all? A few people, quite a bit. Yeah, that's good. So you can see it's nothing crazy, pretty common templating language. And you can see here we're setting up 3 variables. And if greeting and name is empty, it will fall back to hello and guest. So you can see a new line and 2 curly braces. Basically, it will execute the template, and it will render, if there is greeting and guest empty, it will render hello guest, welcome to Pinterest. Now you can see we have a module call, and module is actually a function call. So basically what it does, it will find a home feed module, it will feed it with the options that are passed in, and it will render the home feed module for you. And does this architecture look familiar for you at all? React people, what do you think? So it seems like the whole process of the rendering fits very well to the React architecture. What we do here, we're reading properties, we do call a child module home feed, we're passing all the properties into it, and it seems like they fit very well into each other, but how can we render React in Python? And for that purpose, as a very first step, we introduced a NodeJS sidecar, a standalone service, what it does, it just renders Nunjucks and our templates on the server side. Thus, it will unblock server-side rendering, and our engineers will not have to migrate everything at once. That's why it's so important. And as a bonus, we'll be able to reuse the same utilities and libraries, and there will be no more duplicating sets of utilities and libraries. So here we have a plan for our migration, and as the very first step, we're moving from Jinja in Python, Nunjucks on the client, to Nunjucks on the server and on the client, and from that we can move on. Now, let's take a look how our server-side rendering used to work before introducing NodeJS Sidecar. As you can see, we have the old architecture, Python Django web server, Jinja rendering engine on the server side, and once user agent sends a request, our Python Django web server will start the rendering process, and as the very first step, it will send a request to the backend API in order to retrieve the initial data for the template. When the data comes back, Jinja Renderer will serially render our components tree as far as it can go until additional data is needed. Worth to mention that this process is CPU blocking. There is nothing else can be done in this process. So we serially render our module tree, and when we need additional data, we send another request, then we continue rendering of the tree. We go as far as we can go until additional data is needed again, and this process repeats over and over until it's fully rendered, and we send back the resulting HTML. Now, let's take a look what happened after introducing NodeJS Sidecar. As you can see, in this layout, we introduced NGX proxy layer. We have Node.js workers. And the whole process starts with the same thing. We send the requests to our Python Django web server. Then we obtain the initial data from the API for our template. And here where it becomes different. We send a request to our Node.js service, which go through balancing layer. And we're starting rendering our tree. We render our tree as far as we can go until additional data is needed. Then we request additional data. And now we send multiple requests. We send one request per each subtree in order to continue rendering process. So as you can see, now the rendering is not CPU blocking anymore. We can parallelize this process. And the responses come back independently as well. So then we continue our rendering process. We something wrong with the clicker, sorry. Here you go. Then we continue our rendering process. We request additional data from the API. And we render our tree as far as we can go until it's fully rendered. And then we send back the resulting HTML to the user agent. As you can see, this process is very similar to what we had before, but now we're using Node.js standalone service, and the rendering process is not blocking, CPU blocking anymore. Also, this approach can be used in any other language. We use it in Python, but if you use PHP, Java, or any other programming language, and obviously having JavaScript in all these languages is not a very common thing, you can use similar approach in order to get JavaScript rendering on the service side. So now, at this point, we solved our first challenge, and we have nunjacks on the server and on the client, and we can start building and migrating our components. Once we're able to render JavaScript on the server side, we can solve our second challenge and figure out how can we render React components inside of the old framework and templating language. And let me give you a little bit of a context about Denzel. Denzel is an object-oriented JavaScript library. It uses approaches that were very common like 3-5 years ago, and there's still a lot of them exist. And on this slide, you can see a Denzel module call and a React component call. As I mentioned before, if you remember, module is a function call. It will find and render a Denzel module, Denzel pin in this case. The same with component, but it falls back to React rendering. So in order to empower our engineers to migrate our service incrementally, we introduced a React-specific bindings with the keyword component that represents the bridge between Denzel and React. So on this slide, you can see a simplified version of Denzel-React Bridge. And let's take a quick look how it works. Once nunjacks renderer meets a component keyword, it will render Denzel-React Bridge instead. The bridge, in its turn, will read all the options and will figure out the name of the React component and its properties. It will pass all these options as a properties to the React component, and it will render React component inside of its own container element. So it will basically override its own. So this is a very simple technique, but very handy, and you can use it in many other templating languages. And some of you may ask a question: how actually React will reuse server-side rendered markup on the client side? And this is one of the very cool features of React. Basically, whenever React is rendered on the server side, it will add a checksum to its own markup. And once the web app on the client is initialized, it will render itself inside of its own virtual DOM. It's not the regular DOM, but virtual DOM, which is very fast. It will render and generate another checksum. If these checksums are identical, then we can reuse the markup and we can reattach itself to the existing markup. Thus, we will not have to replace the existing markup, which will lead to a lot of flickering and other performance issues. You probably would notice it. So this is one of the cool features of the React. So now we can talk about third challenge and dealing with the old API layer and the library which does all the data communication with the API for you. And for that purpose, we use higher-order components, or simply HOC. And HOC is a very powerful technique. The definition is it's a function that takes a component and returns another component. It's a powerful technique that lets you to reuse components' logic while remaining them composable. I know that might sound a little bit tricky, but let's take a look at the example. So on this slide, on the left-hand side, you can see a higher-order component with the resource. And on the right side, you can see an example of usage of this higher-order component. And we use HOCs in many places, but the main one is dealing with the old resources. So here, what happens on component did mount lifecycle event, it's basically when component is added to the DOM, it will create a resource and send a request to the API. Once the data comes back, a callback function will update its own state with the newly received data. This will trigger rendering of the HOC component, which will actually trigger rendering of the subject component. With this approach, you can keep your components and data in sync all the time. So it's pretty powerful, but pretty simple and very handy technique. You can use it like anywhere, whenever you want to deal with any data sources and layers. So at this point, we can render JavaScript on the server, we can build React components, and we can supply data for them. Now, let's take a look into the last and fourth challenge. And the fourth challenge is how can we measure the impact and how can we make sure that newly created React components are actually performing better than the old ones. And with 175 million of users, we roll out things very carefully. We want to make sure that newly created UI actually performs better than the old one. For that purpose, we're using A/B testing framework, and we have a framework called Gatekeeper. How many of you are familiar with used A/B testing frameworks before? I can see some hands. That's good. If you have something similar in your project, that will be super handy in migrations like that. So A/B testing frameworks are usually used to measure the impact of your UI and for testing new features and things like that. On this slide, you can see a simplified version of experiment setup. Basically, we check if user passes React experiment check, then we render a newly created React component pin, and otherwise we fall back to the old Denzel component. Now, let's take a look more deeply into how we set up experiments. On this slide, you can see that at some point on some Denzel node, we fork our logic based on the experiments check. And the whole right subtree is fully rendered in Denzel, and the left one is fully rendered in React. It's important to notice that we don't have Denzel calls from React. So once you migrate it to React, there is no way to go back. This is a conscious decision we made that helps us to make migration much more cleaner and well thought. Can you imagine what would happen if you will allow people to call Denzel inside of React and then vice versa? So it would be a total mess. You don't want to do this. So because of that, we have to migrate everything from the very leaves and to the very top. We call this bottom-up approach. And as I mentioned before, it makes the migration much more cleaner and well thought. Also, it's worth to mention that more likely you want to run your experiments at maximum per page level. You don't want to run experiments your old web app against the new one. Otherwise, you have too many factors affecting your metrics and you will never figure out where the metric drops are coming from. And also for the same reason, you really want to run all your experiments exclusively. You don't want to different experiments to affect your metrics and user in different ways. So this is a very important part. And later on, we can log in into our experiment dashboard and check our experiments against such metrics as user wait time, engagement metrics, performance metrics, error rate, and so on and so forth. On this slide, you can see a screenshot of our experiment dashboard. There is a small subset of metrics, and here you can see search engagement metrics. And on the right side, there is a lot of squares, which represent the metric, how it works, if it goes up or down or neutral. So basically, the blue squares means that we have some improvement, and which is good. The red ones, that means that we have a drop. The gray ones means that it's neutral or not statistically significant. And running experiments during any migration is very critical, as I mentioned before. Even if you have a really good test coverage, even if you have auto tests, unit tests, or manual testing, unlikely you'll cover all the edge cases and corner cases. For example, what if your bug exists in countries with poor internet connection or in different languages? So catching all of these with tests is really hard, but with experiment dashboard, you'll always see a drop. And if you see a drop in user engagement, maybe there is a bug or maybe there is a performance issues, and you'll get the signal that will help you to investigate. Pinterest profiles was the very first user-heavy page that was successfully converted to React. And during React migration of Pinterest profiles, we've seen consistent performance and engagement improvements. For example, such metrics as DOM interactive, response end, or board page views were improved by 20%. And these 20% were gained only from gears and infrastructure change without any design changes. I think this is pretty cool. And while we're converting Pinterest profiles to React, our product engineers were able to continue development process and making changes in many other pieces of our website. And finally, all of these leads to a completely new developer experience. So now we don't have duplicating libraries in Nunjax and Jinja anymore. We actually don't have Nunjax anymore, and it makes onboarding much easier because people don't have to learn Nunjax at all. We have single language on the client and on the server side, which helps even more. And the last but not the least, now we are part of the large developer community, and we don't need to create all these wiki pages. Our engineers can go online and find everything in well-crafted documentation. So it's been a long journey, but we're excited to be a part of React community. Thank you.